I'll get through that. Mary, I'll just email you privately about what I need you to do, if that's okay. Okay, sounds great. So, yeah, Samantha and Mary are my remote people, so truly remote. So I'll work with you guys about what y'all need to do. Okay, so there's a couple of questions going on about the test this week, so let's start with that. The first one's always the weirdest one, and this one's the weirdest of weird. If you don't know the teacher and you haven't worked with that teacher before, sometimes you're like stressed out because the test is coming. Does everybody have sample files? Mm-hmm. Did you get sample files? I can get them. Okay. No problem. All right. And sometimes you're like, I don't know how this teacher grades and how their tests are going to look and that kind of thing. So we'll talk a little bit about that, but I also want to talk about, I'm looking for my list of names, about who's going to be where. So I have 2 remote people that I know of, Samantha and Mary, and you guys will be taking remotely with your own testing centers. So I'll work that out with you. And then I have 10 people who said they want to be here in Commerce. I'm looking for that list of names. Where did I put it? All right. I'm not seeing it, so you guys can remind me. I'm pretty sure I know who it is. Oh, why it's not on the sheet of paper? Oh, there it is. Ah, just one I gave up. All right. Demondre, Summer, Ashley, Ryan, Christina, Alexis, Garrett, Jessica, Elijah, and Maria. That's my 10 who are coming to Commerce to be in Binion 329. Is that right? Sounds good to everybody? Okay, so we have 3 options. Option number 1. You're remote in Mesquite or Navarro. And I'll work it out privately with your testing centers. Okay. Option number 2. I have 10 seats in Binion 329. And I just named out those 10 people. So that takes care of 12 of my 17. There's 5 more of you out there. So the other 5 of you will be going to the ATC, which is Ferguson 308. Okay. So, or if you're still having issues, you're going to talk to me, send me an email, that kind of thing, and we'll work something out. But the Ferguson 308 one, if you haven't tested there before, it's the Commerce Academic Testing Center, and you'll need a picture ID. And you'll go in there and you'll tell them you're taking a geography test for Dr. Webster. A couple of things that are available to you. You can either take your own calculator or, which of course that's your own calculator, so it's hopefully germ-free-ish. If it's a graphing calculator, they will clear your memory, okay, in the ATC. So make sure you don't have any programs you don't want to lose or something like that. Or you can borrow a calculator from them. Okay, calculator if you have it. If you don't, they have calculators down there. What they're supposed to be doing is wiping them with disinfectant wipes in between each student that uses them and letting them set out for a little bit before they give it to the next person. So there are some sanitizing things in effect. However, it's less germy, of course, if you take your own calculator. And then we also have, you will want your compass and a straight edge ruler, okay? if you don't have those to take with you to the ATC, again, they have them over there. You can ask for a manipulatives box, and I'll put on the form that you can use the manipulatives box. So they have compass, they have ruler, they have all kinds of stuff in that box. So if you don't have yours, it's okay, they have them. But again, I can't swear to the cleanliness of a community manipulatives box. So again, they're supposed to wipe them, and hopefully they are. That's all I know about that. Okay, so take your own would be my suggestion. And of course, a pencil, eraser, all that good stuff. All right, so that's what you need there. If you're going to the ATC, it doesn't have to be during class time, during the 2 o'clock slot. It would be good if you could go during the 2 o'clock slot, just so you're taking it as same time as everybody else, and you get it done and all that kind of stuff. But Thursday, I'll have it over the Thursday morning at 10 a.m. So that's the other thing. Their hours are 10 a.m. to 6 p.m. on Thursday. Okay. There you go. Hope that makes sense. If you have other special circumstances, I think there's 1 or 2 of you that have talked to me directly. We'll work that out. Okay. All right. So I'll just send a test with everybody else's names on it over there. Unless you scream at me and say, we got a problem. All right. Sounds good. Okay. So then there's a question that always comes up about formatting. So for me, if you've never taken a test from me, the way that I format my test may be a little unusual. There could be matching. There's probably not matching on this particular test, but there could be matching. Those are always a half a point. Don't spend much time on matching because they're not worth a lot of your pointage, right? But the ones that you're almost guaranteed are a true, false. Okay, those are worth 3 points. And the thing about my true, false is you don't just get a 50-50 shot, okay? So if you guess, but you don't get it correct, at least you did something, you're gonna get a point. Okay, I do give partial credit. However, I know guessing happens sometimes with true, false. So what you should do is not just guess the answer, but you'll notice on there in the directions and in each question it says why or why not. So you need to explain why or why not. For instance, here's a really easy true, false question. True or false, in order to do a construction in geometry, you're allowed to use a protractor and a ruler. False. Okay, so if she said false, she'll get 2 points because she's correct. It's false. Okay, she's not going to get 3 points though unless she tells me why or why not.
Don't give exact measurements to things that we construct because of, we talked about this.
Compass and a straight edge or what? It should be compass and straight edge. So the first thing is you could just correct the statement, right? And you could mark out where it says protractor and ruler and you could say compass and straight edge, and that's okay, that's plenty. But if you want to give me a reason, you could say it requires compass and straight edge because it's more generic or something like that, okay? But you need to correct the statement if it's incorrect, okay? Those are actually, in my opinion, falses are easier to correct because there's actually a correction to make. It's actually harder to support a true, okay? So you need a reason to support the true. So for instance, if I said true or false, you use a compass and a straight edge in geometry to do constructions, that one's true. And now you need to say, because we want it to be a generic something, or, you know, we don't want to measure exact angles. We want it to work all the time or something to that effect. So that's the way that goes. Yes, Matt, I'll be glad to look at some of that in a little bit. So that's what's going on there. Okay. All right, true, false. And then multiple choice. Also worth 3 points. Also difficult because it'll be select as many as are true. Okay. So for instance, if it was the same question, I'm just going to beat that one question to death. So y'all be ready for Thursday. If it said multiple choice, which of the following are tools that we use for construction? A says ruler, and B says straight edge, and C says protractor, and D says compass, yeah, you're going to pick B and D. So don't just find B and say, oh, straight edge, that's it, and move on. Keep looking, read all the answers, okay? Because sometimes you might have 2 answers or 3 answers, or there might be an all of the above, which gets all of those answers. So read your directions.
Will it say whether it's like multiple choices or like 2 options or 2 correct answers?
It says select all that apply.
Okay.
Yeah, so you have to know, oh, there's only 2 of those that work. Absolutely.
Will it also say that there's only 1?
Yep.
Okay.
Yeah. Yeah, so dang it, I have to know what I'm looking for there. And so that's kind of the tricky part, because you might see B and circle B and be done. You're going to get 2 points because, first of all, you did the problem, so you get 1 point. And then, second of all, you got the right answer, part of it. But you're not going to get all 3 points unless you give me both answers. Does that make sense? So you're going to get partial credit in there. It's just going to be like, oh, okay, what are we looking at? Okay, those are multiple choice. There's short answers. These are with 4 points. Okay, I would consider a short answer one of the things where I did a puzzle of some kind, and I said, gave you a couple of measurements, angle measurements. Maybe I give you 3 of those angle measurements and say, find the rest of them. Boom, 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 boom. So you're kind of going, okay, angle 1 is 30 degrees because it's vertical with 50 or with whatever, and that's, or 3 and 4 are both 30 degrees. So I give you this one's 30 degrees, and then you say, oh, 4 is 30 degrees. Okay, so you're just kind of filling in the blank, if it were, or a short answer, that kind of thing. So 4 points, a little bit of work, but it's not crucial. Okay. And then your calculation problems, or in this class, we have proof problems, or with 5 points. There might be some calculation problems, but most of our problems in this class are more proofy. That are the really beefy ones. They're more expensive. So, and for the proofs, you're guaranteed to have 1 flow chart that I give you, and you have to fill in some blanks. Okay, so that one's a pretty good 5 points. And then probably 1 where I make you do a 2-column proof, and then 1 that's it's up to you. Normally I do 3 in this class. Okay, so that's kind of the layout for my tests. I'm going to give you an idea of that. And this will be the layout for all of my tests, exam 1, exam 2, and the final. I didn't put matching, I said it, but I'll put it just in case. Don't spend so much time on matching because they're not worth much.
So if we didn't want to do a paragraph proof, we wouldn't have to?
Correct. I do not force you to do any paragraph proofs. It is an option on the do it as you want to, because some people like those, but I'm not going to force you to do one because it just gets wordy sometimes. And then I have to read all that if people get wordy. So, yeah. Okay. And then we had a question that was, what about this optional final thing? So on your syllabus, let me do some date searching real quickly.
I guess what I was wondering just was that where I was going with my questions was, is an A an option without taking the final?
Yes. Okay. So we're wondering how this optional final thing goes. Okay. And I don't blame you because that's like, oh, what's going on? Okay. So for us, we have a couple of things going on. This week is exam 1. Your project presentations. Everybody remembers that you have a manipulative that you're supposed to be finding articles about. That's a good thing to do this weekend after you finish your test, if you have nothing else to do, because you're not going to have homework. You can work on that semester-long project. It's a semester long for a reason. Okay, so you're finding activities on dice or tangrams or whatever, right? Okay, so you find your activities. You're going to do a project presentation. It's 5 minutes per student. Okay. We will spend most of week 13 doing that. This is week 7. Okay, so this is going to happen quickly now that we're at about the midterms points. So don't forget that's out there. We'll do that. We have exam 1 is week 7, week 13. I can't write. And exam 2 is week 14, which is Thanksgiving. It's the Tuesday of Thanksgiving week, right? And then that's our last in-class day. We don't meet face-to-face after that. What I'm thinking about doing for review week, usually I would just come into class and ask a bunch of questions all week. I might do a Zoom meeting that week, and then I might do a video. So like one day you could meet me face-to-face if you have questions about the final, review questions, and then one day where I just put up like review questions in a video, and you can watch it if you want to and not watch it if you don't. If you're not taking the final, you don't have to do the review, right? So you could theoretically be done by Thanksgiving. There's Thanksgiving. And then the question for Maria was the final, since we're not going to be in here, it's online and proctored through Zoom. And if you get to that point and you want to take the final, then I'll get you information about how to do that. Okay, so don't stress out about it. How am I going to do that now? Because it could be that you don't even want to do that. So the idea is over Thanksgiving weekend, I will grade exam 2 and I will post your grades in D2L. If you would like, well, you guys aren't even coming back. I'll probably just scan them and upload them into D2L so you can see them. Okay. So, and once I enter that grade into D2L, hopefully by that point, your grade book is completely updated and you know what your average is. Let's say by the Tuesday after Thanksgiving, you will know what your average is, okay? So then, Maria, if you had a 93 at that point, after I grade exam 2 and all your grades are filled in on D2L, then there's one thing left that's called a quiz for, I think it's like quiz for final exam or something like that. And it's basically you go in and there's like 3 options. I'm good with my grade. I don't want to take the final. I need to take the final, or I'm not sure, I think are the 3. So if you have a C average and you're like, oh, it's because I bombed exam 1, you're probably going to want to take the final because you're going to want to replace exam 1 with the final exam. So those are pretty easy to kind of know, oh, I need to take the final. But some people, like, I had a student in the spring who had an 88, and they were like, I want to take the final, but can we talk about, you know, what kind of grade I need to make on the final exam? And it's actually pretty high because it's your overall average, not just one grade, right? So it takes a lot to boost an average with one test, okay? It's like really a lot. So when we did some calculations, they were like, oh, I have to make like a 98 to make an A or something like that. Okay, I'm not going to do it. Okay. But some people were like, oh, I know I made a B on exam 2. I know I can replace that. That's easy for me to pull up a B from a B to an A. So we can talk about those of people that are borderline. If you're like, oh, I'm so close, is it worth it? Then we can have a conversation. We can Zoom or whatever. Yeah. So that's why I said it's tricky. It's a little bit tricky. If you have an A and you're happy with your A, you're just going to take your A. And the way I do it is D2L. I don't know if you've noticed or not, but right now it's probably only giving you an average in your, what does it call it? Like final calculated average, something like that. I think it's something along those lines. And right now, if you look at it, it's probably only giving you a number out of 50, okay, or something to that effect. Because right now, all you have in there is projects and homeworks and quizzes. It might not even be 50. It might be like 40% or something like that, okay? But once we start putting exam grades in, that's an extra however much, then it'll change and it'll say some number out of 75. Because now you have exam grades and that's everything except for the final exam, okay? The final exams were 25 points. So this will be your grade going into Thanksgiving week or going into the review week after I've graded your tests. So if you look at that grade and everything's filled out except for the quiz on the final, and you're like, I'm good with that, because it also gives you what percentage that is, right? Okay. So if that's a 95, take it and run, baby. Okay. Unless you have a particular reason why you're like, I really want to see what the cumulative final looks like, there's no reason, because you're not going to improve it on a 95, right? If you're a person that you're like, hey, I'm happy with my B, or you may not be happy with it, but you've been making B, solid B's all the way through on the exams, you're like, I'm probably not going to be able to raise that. Okay, if you're B. And so then you've got an 81 that's really hard to pull up. Okay, so A's and B's, most of those people are normally like, oh, see ya, bye-bye now. And so you take that. But if you're a C student or below, you probably want to try to improve your grade. Then we take the final, then it's out of 100. And that's how it turns into an actual percentage, because then I take it out of 100. But if you stop here, that was Ryan's question, what if I don't take it at all? It's not going to count against you. The count against you is if you take it and it goes into the 100%, but you don't do well on it. Because if you take it and I grade it, it's going in the grade book. Okay, so somebody's like, can I take it and see? I was like, no, we're not doing that. So you got to make that choice beforehand, and that's what that final quiz is about. All right, hope that makes sense to everybody. That answered everybody's questions? Awesome. Okay, that's what we're looking at going toward the final. We'll talk more about it as we get there, if you have actual questions when we get closer. Hopefully it's not crazy. Yep. We're almost halfway through this face-to-face semester. Moving on. All right, what about sample questions? Oh, Matthew has a particular homework question. Which homework are we doing?
I think just what homework is due.
What's due tonight?
Parallel.
Oh, proofs? Oh, I don't want to do any more proofs. Is it over proofs, Matthew? Do you have a particular one? Proofs all week last week.
I think you should talk about what is due.
Yeah, like a confirmation of what's outstanding and due.
Thank you. Sorry, Matthew. What is due? Got it. What is due? I don't know. You have a couple of things outstanding, so keep me honest here. All right, tonight is proofs about parallel lines. Right, special angles, all that, okay? And there were 12, and I think we did at least, or touched on at least 5 or 6 of them, right? Okay, so that's what's due today. You were also supposed to let me know about your testing arrangements by today if you have any issues.
Yeah, that's due next Tuesday.
That's due on Tuesday, right? Yeah, so that's the 13th.
Mm-hmm.
And reading.
GeoGebra. Yeah, there's a lot of reading out there. If you haven't finished out that reading, or at least attempted part of it, remember it was a bunch of reading out there. All the rest of this stuff is already due. This stuff's already due. Oh, the participation things. Here's I found my paper. Isn't that lovely? After I start writing on it. So the participation things we had, it was, I think, 3.7 flow charts. That was Tuesday, last week. We did all of those. So if you have not if you were not on Zoom and you were not in face-to-face, then you need to do those flow charts and load them into that participation folder, okay? The Thursday was the 5.7 flow charts, but we only did one of them, am I right? Or did we do 2? 1, 2? I think we only did one of them. Okay.
Yeah, we did number 2.
3.7 all. 5.7 number 2, she says. And so you don't have to do the whole 5.7 thing, you just have to do what we did in class. So if you're in Zoom, you should be able to go to your participation grade and see that you already have 100. Okay, if you were in face-to-face, you should already have 100 in D2L, so you don't have to do anything. This is for the people who are not physically present whenever I'm teaching, and so I want to make sure they're keeping up, basically. So especially with these proofs, they're so rough. Okay, and then the thing for last Tuesday was the 13.2, how to plan a proof. And we did number 2 and number 6. Okay, so that's what we did in class those days. So again, you don't have to do them completely from scratch. If you're like, oh my goodness, proofs, go watch the video and do them as we do them, and then fill in your thing and scan it and upload it. But don't forget those are out there. And that's it. Yay. Yeah, don't forget your semester-long projects out there. You're supposed to be finding articles or activities, etc., right? And you're going to make this into a presentation that you share with class. Something about your manipulative. You're welcome. Very good. All right. Okay, cool. Now, that's what's due. What else we got? Did y'all look at the practice problems? I hope. A deductive argument. Calculating angles. I love these diagrams, guys. I don't know how many times I've said that in this class, but you're gonna see some on the test on Thursday. Be sure you know that. Okay. Calculating angles, I consider them like puzzly things. Flow chart proof. Which segment is the shortest and how do you know? Okay. This is number 3.
I know what the answer is. I just will explain parts would probably get you if that one was on the test.
Explain gets a lot of people, so you're not alone. Don't feel bad about that. Okay, this guy is a large triangle that has a smaller 2 triangles inside of it. This is N-A-L-E, or maybe it's lane, L-A-N-E. 61 degrees at angle N. The left-hand side of A is 59 degrees, and the right-hand side is 121. Is that 29? 29 degrees, and up here is 30. Hopefully that adds up. Yes, did y'all add them? 151, 160, yeah, okay. All right, so it says which segment is the shortest? AE, right here, she thinks. Okay, and why?
Because
The bigger angle usually is on the opposite side of the longest side.
How big is this angle, do we know?
50.
60, 60,
Yeah,
60.
60.
Okay. So basically, we can probably ignore this smaller triangle because all of those angles are bigger than the little angles over here. Does everybody agree with that? Okay. And I mean, this up here is a 90-degree angle actually, so the whole big triangle is 90 as well. All right, so then we said, well, the smaller angles are over here. So just focus in on this small triangle EAL, or maybe it's ALEAL. I don't know. Okay, and Ryan says, look, Leah. Ryan says that this angle L is 29 degrees, which is the smallest of the angles. Okay, and so Ashley said that makes this guy be the shortest. Okay, so when we look at that, we say, okay, well, if that is the shortest of those three in that triangle, how can I explain it? And that's the concern. Okay, so the way I would explain it is I would look at triangle LAE, and I would say, hey, looky here, it's got 121 degrees. And what Ryan said was the biggest angle is across from the longest side. And that is correct. Okay. Smallest angle is across from the smallest side. What? You're looking at my solutions?
Yeah.
Okay. Are we right?
Yeah.
Yay. Okay, good. Make sure we're right. Okay. The smallest angle is across from the smaller side. There was one similar to this in one of the homeworks. I remember.
That's what I wanted to ask.
Yeah, we talked about it, right?
Well, can you go over a problem that is a parallelogram that has several triangles in it? Like, it's a parallelogram with two diagonals to create four triangles. Like, I think that was a homework problem. And we had to see which segment is.
You talking about number 3 on lesson 5.7?
Yes, I believe so.
Or was it a flow chart?
Yes.
Hang on.
Very close. I think it was a 4 point.
I was just looking over at it while we were talking about the test. I was like, that sounds familiar.
Sounds like something you may have worked before, right? Okay, so anyway, the reason there, back to Ashley's question, the smallest angle is across from the shortest side. Now, what the question was before, whenever we were talking about one of these, was, well, how do I know that's different than the big triangle? Okay, well, the big triangle, so the weirdness is, does this 29 degrees go with this side, or does this 29 degrees go with this far side? And the answer is yes, both. Okay. It goes with both of them. So when I look at the smaller triangle, the 29 degrees is the smallest of that. Just don't get it confused with whenever you're looking at the bigger triangle. So now we are comparing the 90 degrees, the 61 degrees, and the 29. But see, it's versus these larger sides. The 29 is still the smallest when you're looking at that larger triangle, right? The 90-degree guy. So it's still the smallest angle. The 90 degrees is still the largest. So this whole side over here in L is the longest side on that case. So
the answer could be NE or AE.
these are not going to be exactly isosceles is what I'm guessing. Okay. Well, I know it's not exactly isosceles because it's got not quite the exact same thing. But if you look at the overall triangle, LEN, let's say, then this guy is the smallest. But if I look at this one, then this guy is the smallest.
So the answer then is NE.
What did the question actually say?
What segment is the shortest? AE and NE we're saying are equal.
Not equal.
They're not exactly
It's
equal.
not an equilateral triangle.
Oh,
Yeah, because
If
it's not.
60, 60, 60, all the sides would be the same length.
Yes, exactly. So then it becomes a bit of, oh, what's going on here? So we might want to actually look and say, okay, looky here, and look inside this triangle too. Inside of this triangle right here, that guy would be the shortest. Does that make sense? So yes. All right, but Did y'all find 5.7? Was that it?
4.3 is the one that, and I asked you about that one, but
4.3.
Number 6.
4.3, number 6. I think it's a similar thing, because we were like, okay, which one? You have to play with the whole thing. I think I already filed it. Oh, that one is done. You did what?
I got minus 2 points on that. That's why.
I don't know. Did she make it so y'all can see your grades on them? Okay. She said they were draft, so I don't know, maybe they didn't go into the grade book yet.
and then you can see your grade, but you don't know why you got that grade. And then the stuff that I didn't get a 100 on, she just put like -2, like over a problem. She didn't show us where we went wrong, or she didn't show me where we went wrong.
She didn't put any, like, show work or. Oh, there we go. 4.2,
4.3.
4.3, number 6? Okay. Yeah.
I have that page.
You don't have it? It was in a
It
packet,
was a homework assignment.
4.1, 4.2, 4.3 all together. So yes, this is a similar type of thing. So I remember we played with it for a while. This is actually one of those things that shows you when you look at the actual picture for this, it's not a parallelogram, it's a trapezoid. That's what was wrong with it. For the trapezoid, we can tell that this guy is not being bisected, right? Because it's just a little piece there and it's long, little piece long. So that diagonal rule doesn't work in trapezoids, we know. All right, so D, A, B, C, 28 degrees, 71 degrees, 40 degrees. All right, so we were struggling with something similar to this. Arrange the unknown measures in order from greatest to least. So A, B, C, and D. We want to know which one of those is the biggest, which one's next, which one's next. Okay,
We also did 2 angles down at the bottom of our congruent.
thank you. This guy and this guy. Okay. So here's where we see though, just because this angle and this angle are congruent, it doesn't mean that this side is congruent to this side, right? Okay, even though these angles are congruent. So what we have to avoid is trying to compare across triangles like that. We have to make sure we're looking inside of the one triangle altogether. So if we can possibly do that. So for instance, if I want to look at the 71 degrees, well, we could look at this big triangle here. Well, it's not the biggest triangle, but this guy right here. Okay. And if we want to talk about B versus C, then I can figure out, well, this angle right here is a large angle, right? So in this triangle, this piece is the hypotenuse, it's the longest, okay? So then which one next and which one next in this triangle? How big is this angle? That's what I need to know. 40, 60, 70 is 139? 139? I'll check my arithmetic. 41 degrees?
That's what I had written down.
Okay.
41.
I'm doing arithmetic in my head. Please check me. Yeah, 41 degrees down there.
40 below
Say it again.
it. 44, the angle below 41.
Oh, down here? Why?
That's
Yeah, it's not a 90 degrees, so we're going to have to watch out for that. Okay, so out of these three, which is the smallest? Well, the angles, I'm sorry. Out of these three angles, which is the smallest?
28. Or if you're considering that one angle, then 40.
Yes, this is one big angle here, right, in that triangle, okay? So this one's the longest, so the smallest is 40. So that means even though my picture doesn't look like it, which one's the smallest side in this triangle? B and then C. Does everybody agree? Okay, so we know B is less than C from there. Is that okay? Now we're probably gonna have to play with it a little bit, but we're gonna use that kind of logic here. So let's see what else we got. Yeah, that's not gonna help me. What other triangles do I know? I know this one, this little guy here. What's this angle here? 68.
I'm sorry, before we move forward,
Uh-huh.
did anyone else get that too in here, that B is less than C? Because I actually have it the other way around.
No, I did not make that. I had ADBC.
That's what I have.
I have A.
Well, you had B is less than C or B is greater than C.
I had B is greater than C.
Me too.
Did we do arithmetic wrong?
What I did, I started with the triangle at the top,
Mm-hmm.
the smallest one,
Mhm.
and found that third angle,
What is this?
112.
112.
And then we know the angle beneath is a vertical angle, so that's also 112, and those other two are 68.
These right here.
Yes.
All right. Then what?
We can find the leftover angle 40 by adding 128 and 28 together to. I mean 112 and 28 together to get 140. So 180 minus 40 equals 40 for the bottom triangle.
Down here. Do I know it yet?
We don't know this.
I did
Yeah,
alternate interior, so the bottom of BA is 40.
Ah. Here.
Yes.
Yes. Okay, so I'm hearing this line is parallel to this line, and this is a transversal. So down here is 40 degrees. Okay, I like that. And then can we use that same process on the other transversal? I draw this guy over here. Here's this interior angle, 28 degrees. So this one down here has to be 28 degrees. And then we know one other thing.
The one above it's 20.
They're congruent, so this one's 28 degrees. Okay, and then we should be able to figure out that last angle. What? I'm just kidding.
84.
84, thank you. Louder, louder, louder. Okay, 84 degrees. Okay, then what?
I just realized I did it wrong too. When I did drawing
Yes.
homework, because I was finding the, I guess, largest one of each triangle rather than the shape itself, like the,
Oh, you were finding the largest
Yeah.
triangles? Oh.
just realized.
Yeah, just the side length, isn't that right?
Yes.
That's what I got out of it. So A is that segment that crosses all the way across the trapezoid. And it seems clear to me A is the largest. Does everybody go with that? But we can probably prove it, show it in a second. But it seems like it's the longest. I think the ones that worry everybody are B, C, and D maybe. Okay. So now that we have angles everywhere, does that help? Maybe? Okay, hopefully. Okay, let's look at the other triangle that's down there. And let me explain why I'm zooming in on the ones that I'm zooming in on, because maybe you're like, why is she looking at those? I didn't look at those bigger triangles. I'm looking at this triangle right here first, because I know that it has B and C as two of its legs. And so I can look at the bigger triangle here, and I can compare B and C. Now, that's not necessarily going to get me B to A or B to D, but I can compare those two and see what's going on. Is that okay? And then we'll talk about what else we got. I don't know what we got. I haven't done this one, worked it out all the way. Even in the hallway, we were just talking, right? Okay, so let's look at this triangle. Okay, I've got two 28-degree guys. See, this one's a little bit tricky. I've got two 28-degree guys, and then this big angle here is the largest angle of those three, right? Okay, 124, yeah. So what do we think about C versus D? This one's a little tricky.
He is congruent to C.
What about those angles? I've got 28 degrees here. That's congruent to this 28 degrees, right? And so that makes this triangle is a what? Isosceles triangle, right? Everybody see that? They're kind of sneaking with me because they said greatest to least, but now I say, oh, wait a minute. Those are congruent because that's isosceles. Is that okay? Okay, so I've got another statement here. C equals D. All right. And so now I think I can do like more or less a transitive kind of thing in there in the middle. I know C and D are the same, so I can stick them in the center. And then we can show A is the biggest. So we can't necessarily, well, we could show A versus B, but I'd like to show A versus D because I want to show that it's actually bigger than this guy. Is that okay? Okay. So when I look at this triangle, again, I'm finding the triangle where I can compare two of the values, A and D. Okay. All right. So then I'm looking at these angles. This one, when I combine it, that's 56. So the smallest guy is here, 40 degrees. So D is the smallest angle or side out of this triangle. So now for sure, D is smaller than A. I have an extra statement. D is less than A. So I can do like that. Of course, they said they wanted greatest first. I would never do greatest first. That one's weird because they're the same size, but there you go. A is the biggest, B is the shortest, C and D are in the middle. They're the same size. That's why we were struggling because it's actually isosceles, so they're the same. What do we think?
It makes sense now, but we have to like.
Sorry, but we're using this particular property. Smallest angle is across from the shortest side, okay? Largest angle is across from the longest side. So using that property, which means the middle angle is the middle side, right? So, except for whenever it happens to be an isosceles triangle, and then it maybe throws us off a little bit. Is that better? Clearer now? Okay. What else? I like these what's wrong with the picture ones. Hint, 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 hint.
Number 4.
Yeah, I like those. What's wrong with that picture? It's saying it's isosceles, right? 20 centimeters, 20 centimeters. It's even marked congruent, but Summer says the base angles are not congruent, 42 and 43. Absolutely. So you could just say base angles aren't congruent and walk on. Okay, it's easy enough to see that. If you wanted to, you could say something like if this was A, B, C, you could say like A needs to be equal to C, or you could say 42 doesn't equal 43, you know, anything that gets across that those two need to have equal measures and they don't.
Can we go on to number 8 because I feel like I don't remember doing anything like that.
Oh, we haven't done three-dimensional stuff in here yet. Okay, so hang on a second. 5 collinear. I think y'all are probably good with that. Writing a proof, we did that for the last 2 weeks basically, so hopefully y'all are better with that. If you need help, we can do one. She says number 8. This is an example of a multiple choice question. Use the diagram below to answer the question that follow. Oh, it's not really three-dimensional. It is three-dimensional picture, but we're gonna use properties now, so valid. I was thinking maybe I'd thrown one on there that's not very nice to you. Okay. Here's this picture. A, C, B, and D. This is number 8 on the sample problems. And it says, in this diagram, DC is perpendicular to the plane of ABC. Okay, so this, think about, this is a sheet of paper down here where this bottom triangle ABC is, and they're saying DC is perpendicular to that. Okay, so what does that tell me? 90 degrees right here and right here. Okay. Because the whole plane, right? So it's perpendicular both sides. Okay, perpendicular to that plane, ABC is equilateral. So ABC is this triangle down here, although my backside looks, my back line looks a little bit bigger. But equilateral means all 3 legs are the same, right? ABC is equilateral. Which of the following justifies the assertion that triangle, so now we're looking at triangle ACD, this guy, is congruent to triangle BCD, this guy. So they didn't give me enough pieces. They only gave me 2 pieces, right? I need a 3rd piece.
Identity of CD.
Say it again.
The identity of CD, it's equal with itself.
Okay, Summer says, look here. This leg is shared between these 2 triangles, right? Okay, so, and we know that this leg is congruent to itself. Same segment, identity, all that stuff. So this guy's congruent to himself. And then Mary is saying SAS, side angle side. So do we see a side angle side situation here? Side angle side, side angle side. And notice that they listed them in the correct order, ACD and BCD. So yes, absolutely, Mary, good job. Can we see it? Side angle side. So that's what? B.
So with this kind of problem, like on your test, like basically the partial credit kind of thing, if we were at least able to mark out like the angle, and then the side angle, like that would be working towards a few points, even if we didn't necessarily ever get to actually circling B.
Yeah. So, and also just if you put, for geometry is a different kind of class, right? So if you put some markings on your picture, if you got that picture like this, and it's just got a bunch of stuff on it written down below it, and you marked for me, okay, I know this guy's congruent to this guy, and you put in the 90 degrees, and then if, you know, you're using the given to show me in your drawing. So you're not always doing mathematics and geometry. Sometimes the drawing is a huge part of the problem, right? So, and it can be a huge part of the solution. So if you told me this guy's congruent to himself, that helps. Yeah, so anything you do. So for instance, Ashley just said, well, I know I'm not going to have side, side, side. So what if I mark out that? Yeah, that's work. Okay. Oh. Well, and we know, okay, we know that these 2, by the way, angle, angle, angle is for similarity, not congruency, right? And we're looking for congruency. And side, side, angle isn't a congruency at all. So that marks 2 of them out. So all you had was B or D, which was side, side, side. So if you know you got an angle in there, well, it's certainly not 3 sides, right? Yeah, you're working towards your answer. So you would get partial credit on that as a multiple choice, even if you didn't give me the right answer. sometimes I'll be like, oh, come on, circle it. Yeah, I talk to you while I grade your tests. Come on, you can do it. Absolutely. So it looks weird, but it's doable. Thought for a minute I had given you content from exam 2. Nuts. We're headed toward 3-dimensional objects. It's coming. It's coming soon. Okay, and then I've got another page of multiple choices. Oh, let's talk about number 10. Excuse me. Oh, wait. Go ahead and read number 9 real quickly for me. This one's interesting. All right, so what it says is a student's basically messing around on GeoGebra, right? And they've got a parallelogram, and they think that diagonals are bisecting each other. Like they've measured those segments, and they see what's happening. And, oh, it looks like it's bisecting each other. So it says, and by the way, this one's on here because this one is actually a released practice question from an old Texas exam, which is the teacher certification exam for Texas, which most of you want to be teachers, right? So which of the following would be the most reasonable next step for the student to take to evaluate the validity of their conjecture? So their conjecture is diagonals and parallelograms bisect each other. Okay, so what should they do next? Try to find more examples supporting the conjecture. Try to find a counterexample to the conjecture. Try to prove the conjecture using mathematical induction. Try to generalize the conjecture to apply to other quadrilaterals. So almost always there's 1 or 2 distractor answers, one that's completely wrong, and then the right answer, right? So what do we think? Talk to me about A. Try to find more examples supporting the conjecture. What would that look like in GeoGebra?
Copy, pasting.
Okay, make some more parallelograms, copy and paste, make sure you're measuring them all, move things around so that they're different lengths on the sides and stuff like that. Okay, what's wrong with that? How many examples of parallelograms can I give you? A gazillion, right? Lots of them. What if there's one parallelogram out there that doesn't use that property, like it doesn't work? Am I going to find it just by getting a lot of more examples? Probably not, right? I'm probably not going to just stumble upon this one weird case by just working more examples that are similar to it. So A is actually that they call that the case process. Find a different case, look for this, look for that, and you could just do this forever, basically. So that's not right. What about B? Try to find a counterexample to the conjecture. That's where I should be going. So whenever I'm thinking about a property, does this work for squares? Does this work for rectangles? Does this work for blah, 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 blah? If I can find the one situation by looking for the counterexample that doesn't work, then we always say one counterexample disproves whatever it is, right? So it doesn't matter if I have 50 examples that support it, one counterexample, I'm out. Okay, so if I see a counterexample immediately, then yeah, that would be the next thing to look for. Well, is there anywhere where that doesn't work? That's what we want to know, right? there anywhere that it doesn't work for a parallelogram? So maybe I'll look at all the different parallelograms. Maybe it works for a square, and it works for a rhombus, and it works for a rectangle, but it doesn't work for a general parallelogram. So maybe look at the different kinds and see where doesn't it work, okay? So that's what I'm trying to find, is something that throws the rule out. Try to prove the conjecture using mathematical induction. What's wrong with mathematical induction?
C seems similar to A to me. That's why I want to pick it.
I actually agree with that. C is similar to A, because what's the difference, remind me, between induction and deductive reasoning? Which one's which? Which one do we use whenever we're doing a proof?
Isn't it deductive with using facts to prove something?
Yes, we use deductive reasoning whenever we're doing proofs, right? We go step by step, logical step by logical step, and we use a statement and a reason, a statement and a reason, a statement and a reason. That's not inductive reasoning. Inductive reasoning is I see a pattern, right? And I think that this pattern is true, and that's why I actually said that's similar to A. I'm just looking for a pattern that always works, but I don't know if always is always, right? So that's a problem. So C is, if we were going to prove, we would prove using deductive reasoning. Okay. Try to generalize the conjecture to apply to other quadrilaterals. Well, we don't care about other quadrilaterals, right? Or we're trying to prove just for parallelograms, because we know it's not going to work for, say, a kite, right? The kite doesn't bisect each other. One gets bisected, but the other one doesn't. So we know it's not going to work there, so why bother? We know in this trapezoid that we just drew, that's a quadrilateral. No, that's not going to work, right? They don't bisect each other. So we know it doesn't work for all quadrilaterals. What we're worried about is, does it work for all parallelograms, which is more specific. So the answer should actually be B there. And this one's weird. I throw some of these out there sometimes because, and you can tell whenever they're from the state exam, because they're like neatly typed up like this. So let's look at number 10. Is everybody okay with 9? We said B. Try to find a counterexample if you can. The next step after, if you don't find a counterexample, the next step would be find a proof using deductive reasoning, right? So that's why C isn't correct. All right, number 10. Read it for a second. Ken kind of follows up on 9 a little bit. A mathematical statement deductively derived from axioms, definitions, and previously proven statements. Oh, I'm sorry. Which of the following best characterizes a mathematical theorem? Okay, so that one's one that's deductively derived. B is a mathematical statement assumed to be true and from which additional mathematical statements are proven. Oh, is that a theory? No, that one's a what? Postulate. We assume postulates are true. Okay, C, a mathematical statement that can only be proven true by indirect deductive methods.
What's that one supposed to be? That's nothing.
Well, there is indirect proofs. There are. If you take like a discrete math class or something like that, maybe a number theory class, you'll probably do some indirect proofs, but you don't have to prove them indirectly, right? You can prove straightforward. And so that one's not. That's not what a theory is, for sure. And D, a mathematical statement that has neither been proven nor disproven. Neither proven nor disproven. We think that's a conjecture because we haven't said it yet. Okay. So which one is it? Should be. Look at us.
Would D be conjunction?
Yeah, yeah.
Okay.
we haven't proven those yet, right? So we have a whole list of conjectures that are like, we just didn't prove them. And what your book does is once it's proven it, like the alternate interior angle conjecture, okay? Once it proves it, somewhere in the book, it'll say the alternate interior angle theorem. And it makes the connection of, it's been proven, so now we can just call it a theorem. Done. Isn't that great? Okay. So there's some of those on there that are kind of a little bit wordy. When you see those like that, that's because those are kind of state board exam questions that we bring in, just so you can see them, just so you realize it's not just because Dr. Webster wants you to know what a theorem is. Okay, but those should make sense because we deductively do step by step by step on those. And we know in geometry, when we're doing reasons and statements, we have to have a definition or a postulate or something like that that we are using to support our reason, right? Anything else on the sample questions? Anybody have stuff they want to ask me? Everybody's ready to take the test on Thursday in 2 days. Y'all are going to be awesome and do a great job. Don't see any questions in Zoomville. And we work on more questions like this in the future, like the problems from the state exam. I can pull some up. Absolutely. Let me make myself a note on that one. Maybe close to the end of the semester, we can kind of just have a bit of a day on that. I will say when people go to take, I'm making myself a note, Miss Samantha. When people go to take the practice test or even the real test, a lot of times it's simple things like definitions and properties and stuff like that that trip them up because maybe it's been so long since you've heard of it. And geometry and statistics seem to be the two areas that people struggle more with, like combinatorics and combinations and permutations. So in your statistics class, so those, they come back at you on the test, and if it's been a couple of years since you took your stats class, you're like, oh my goodness, I don't remember how to do that. So sometimes that we'll struggle with that a little bit. All right, I'm taking a roll real quick. Other questions? Where's my cursor? There we go. Nothing? All right, then I'm going to stop the recording. Give me a second to call roll.